Hello everyone, this is Evolution with Henry, and today we're going to be going over the evolution, or the evidence of the evolution of the northern giraffe. So just some overview about this giraffe. Its males are about 18 feet tall, females 14 feet tall, and both genders weigh anywhere from 1,200 to 2,600 pounds. They have two horn-like structures, well males have three, but they're on their head, pretty unique to the species. They live in loose herds. Males usually are solitary when they're older. They live in savannas, shrublands, and East and Central Africa. They're herbivores, and they mostly browse on leaves and twigs of trees, especially acacia trees, which is something we'll talk about more later. On the tree of life, like their lineage, they're closely related to David's deer, and honestly pretty close. They have a common ancestor with horses, sheep, yak, cattle. So the fossil evidence of giraffes show a common ancestor with Civatherium and the Paleotragus, which are pretty much just other types of giraffes, but like prehistoric, they're stockier, smaller necks, these much bigger horns. Then comparative anatomy with other mammals, their limbs are similar to pretty much all other mammals, so well that even includes humans. So one of their bones is big, for example like a femur, and then two other bones after the joint would be like a tibia, fibula, and then tarpals, and then they have hooves. Then when we're talking about their embryos, they are actually pretty distinctly giraffe embryos. They have a tail bud, and their neck is significantly longer than most other embryos, and there's early facial structure, and it's pretty obvious that it's a giraffe. When we go down to the molecular evidence for evolution though, giraffes share much of their DNA with like okapis and deer and cows, and they have similar genes and proteins also, such as hemoglobin, and so this shows that they all share a common ancestor. Even like unique giraffe traits like really strong blood pressure are based on shared genes, but with slight mutations, and we'll actually come back to those gene mutations in a minute. Right now I wanted to talk about the mechanisms of evolution, in this case natural selection. So natural selection has acted on the northern giraffe in a lot of different ways. For example, the selective pressures that have acted on northern giraffes have been competition for food. That's really driven the giraffe necks to outgrow their competition so they can retire leaves, especially in acacia trees. And then predators have also driven giraffes' neck growth because now giraffes can see like lions from further away, especially even when it's brushy. Then some fitness adaptations that have driven the evolution. Well, its long neck, we kind of already covered this, but its long neck allows it to reach higher than other animals, and its heart and blood pressure system are really strong compared to most other mammals because it has a really long neck that needs blood up and down. A real world example of this would be like in the dry regions of Africa, the giraffes with longer necks can eat more, and that gives them a health advantage, which leads to mating advantage, and so over generations, this led to a population of giraffes with even longer necks. Now when we talk about the other processes aside from natural selection, we got genetic drift, and so like a lot of the causes of genetic drift have been like civil conflict in Africa, and it's led to a decrease in genetic diversity because it's also lowered the population of giraffes. Then as far as gene flow goes, interbreeding has been going on with giraffes. It's actually been a benefit because it's allowed genes to move between populations, and it's increased giraffe disease resistance actually, so that's a positive. And then mutations we've kind of covered already, but a specific mutation that has helped with the strong circulatory system in giraffes has been the FGFRL1 gene, and it's a mutation that just strengthens blood vessels. That's a pretty common one, and it's just becoming more and more common. So we're kind of seeing some evolution in action. Specification, I meant to say, patterns of evolution when it comes to the northern giraffe. Well, there's been a lot of divergent evolution. For example, like okapi and giraffes were very similar at one point, or at least evolutionists like to say. But because of geographical differences, okapi stayed in forests, giraffes kind of went to savannas, and so giraffes' necks had to go to reach food, while okapis stayed short because they had food on the ground. There's also been convergent evolution. This one's less specific, I should say, because all it's been has just been like its long legs are similar to other herbivores, just because of similar selective pressures. And then coevolution has been happening with our acacia trees because giraffes feed on them, acacia trees, and apparently acacia trees have also been evolving and developing chemicals and thorns, but giraffes have been evolving with them, and so giraffes can tolerate that. Well, they eat around the thorns, but they tolerate the chemicals. Lastly, before we end this video, I would just like to actually predict the species' future, and so I just wanted to. My guess is that if pressures like habitat loss continue, giraffes might become smaller because less food, and so if a giraffe needs less food, less maintenance calories, then it'll survive when there's less food. And then also, I was thinking that they might evolve to just keep developing stronger disease immunity, because that's kind of going on right now as well. And all said and done, I'll show you a really cool picture of a giraffe that I drew with my hand. And thanks for watching.